Okay, welcome back to Subnetting, part 5. Now we're going to discuss something a little different, a little more different than what we've been discussing before. Let's go back to what we had before. Remember this address? We had this in part 4. I needed 6 subnets, but now I'm saying I've got this kind of a deal over here. I need 4 different networks. So let's just look at this for a second. To get 4 networks on my chart, I come over to the 4, I notice that's 2 to the second power. That means I have to steal 2 bits. So if I add 2 bits to this prefix, I come up with /21. Okay? That's my prefix. That's my network size. If that's my network size, how many bits do I have left over for hosts? Let's take 32. Which is the total number of bits I have, right? 4 bytes of 8 minus 21. That leaves me 11. So I've got 11 bits to define hosts. Okay? 2 to the 11th power is a big number. Yeah, not that big. 2 to the 11th is 2048. So each one of these networks, of these 4 networks, can have 2048 hosts because I'm using /21 for my network. That leaves 11 bits left over in every one of those networks for hosts, and 2 to the 11th power is 2048. But let's look at what I really need. I need a network that has 1,000 hosts. So basically, for this network, I'm throwing away 1,000 addresses. Here I need 500 hosts. I'm throwing away about 1,500 addresses. Here I need 200. I'm throwing away 1,800 addresses. Here I only need 60 addresses. I'm almost throwing away 2,000 addresses that I can never use again because I've taken that address and I've divided it into 4 equal subnets. So what we're going to do is we're going to see how we can modify what we do a little bit in order to save some addressing space. You know, in our private network, if we're not really concerned about saving address space, that's fine. But we did create variable length subnet masking, VLSM, and classless interdomain routing, CIDR. CIDR allows us to use prefixes that are not on byte boundaries. Okay, this is all in your curriculum. Go back and read this if you need to refresh it. I'm going to show you an easy way to come up with 4 subnets that are variable size. Very easy way. If you do this, you have to understand the mechanics behind it. So go back and review all the other lectures, but this is quick and dirty. First thing you need to do, first thing, and never forget this step. These have to be rewritten from top largest to smallest. Always go from your largest to your smallest. So I'm going to take B and put them on the top at 1,000 hosts, and A below that at 500 hosts. The rest are in line, 260. So you go 1,000, 500, 260. If on your final, or if on any quiz or test you get these out of this order, put them in this order. Very important point to remember. It'll work, but it'll get very confusing for you very quickly. So always put them largest to smallest. Now, let's take a look at what we got here. We've got this address. Again, we need 4 subnets, but we want to do variable length subnets. So let's take a look at the best way to do that. I need 1,000 hosts here. So how many bits do I need to get 1,000 hosts? You're going to have to go beyond your chart. You're going to have to think up a little bit. 2 to the 7th is 128. 2 to the 8th is 256, 2 to the 9th is 512, 2 to the 10th is 1024. Okay? Some facts here for you that may help. 2 to the 10th is 1,000, 1K. 2 to the 20th is a megabyte. And 2 to the 30th is a gigabyte. Okay? You get back down from there. So if I need 500,000, obviously I go down 1. 2 to the 19th is 500,000. 2 to the 20th is 1,000,000. You double every bit you go up. You halve every bit you go down. That's just a little interesting fact there to help you try and fill in some of the higher voids. So for 1,000 hosts, I'm going to need 10 bits. Is that correct? So if I'm taking 10 bits for my hosts, how many are going to be left over for my network? Here again, you got to consider that we have 32 bits total. I just took 10 for my network. I have 22 left over for my network. 22 is the number of bits in my prefix. Let me write that down, /22. Okay? Here, I need 500 hosts. That is 2 to the 9th power. Okay, 2 to the 9th power is 512, minus 2 is 510. Remember, you always got to subtract 2 for all zeros and all ones. So 512 minus 2 is 510. I can get 500 hosts with 9 bits. So how many bits are left over for my network? 32 minus 9? Yeah, 21. Good math, John. Good math. 32 minus 9 leaves me 23 bits. Okay? 23 bits is my prefix, because that is the size of my network. Okay? 200 hosts. How many bits do I need? Now here you can get back to your little chart and come across, no you can't. You can get to 128, 2 to the 7th power. 2 to the 8th power would be 256. Okay? So that falls within that. So that's 8 bits for my hosts. 32 minus 8, 24. I need 24 bits for my network. Okay? 60. Now you can use a little chart. Woohoo! 60 bits, if you come across bit positional value, is 64. Now remember, we got to subtract 2, so 64 minus 2 is 62, but that's still okay. But if I had needed 63 addresses, 64 there is not going to cut it, because when I subtract the 2, I only have 62 left. Be very careful of that. People will, on tests and on certification testing, give you 1 less than the positional value, but you've got to subtract 2, so you've always got to go up 1 more positional value. In this case, we're okay. So 64 is 2 to the 6th power, so I have 6 bits for my hosts. So I'm going to have 32 minus 6. I'm going to have 26 left over for my network. 26 bits for my prefix, /26. Okay? That's the first step you should do. Well, the second step, if you consider putting them in highest to lowest order, the first step, figure out the network prefixes next and write them down next to those values. Okay, now we can get to work. We can always use that first address. Okay, we can't use /19, but we can use that address. So my first network, or actually my network B, is going to have an address of 172.16.32.0/22. Okay, I'm going to use the network prefix I just worked out. I'm going to put it here with my address. Okay, now the only thing we have to do from here now is figure out how big each one of these networks are, how many hosts can be in each one of these networks, so that we can figure out, how to go down from there, or what the next network is. So let's look at the /22. If you come up here, /22 on your little chart is in the 3rd byte. So we're really going to change this byte here. And /22 says it's got a positional value of 4. So we're going to add 4 to that. So my next network should be 36.0. Okay? I changed that by adding 4. Based on that 22. Now, this is my next network, but this now becomes its prefix, /23. If you look at your chart, you're still in the 3rd byte. The bit positional value is 2. So again, I'm going to change this byte, but I'm only going to add 2 to it, 38. Okay? Everything else stays the same. 172.16.38.0 / what? What am I going to use now for my prefix? Obviously, I'm going to use this 24. Okay, notice in your little chart, 24 is still in the 3rd byte. So my change again is going to occur in the 3rd byte. 24 has a bit positional value of 1. So I'm only going to increase this by 1. 39. Oops, 39. Okay. Everything else remains the same. 172.16.39.0 / 26. So I'm bringing over my /26. Now, if I needed another network, let's just take this out one more so you can see what happens. If I needed another network, I'm going to base it on this /26. That's in my 4th byte. Notice the positional value is 64. So now I'm changing this value, and I'm going to add 64 to it, and everything else remains the same. Whatever I got here. We can leave it at 26 if we want, because we don't really need it. Okay? Now, these prefixes are also going to tell you, well, not really. Okay. But you can see that here, if we're using 26 for the prefix, we're only using 6 for the host. 2 to the 6th power is 64, and we got to subtract 2, so that leaves us 62 possible addresses for the host. Look at this, out of 62 possible addresses, we're going to use 60. We only wasted 2 addresses. Not a bad deal. Here, 254, we're using 200, so we wasted about 50. But that beats the thousands of addresses we wasted before. Here's how it works. Go back over this video one more time. Use your little chart. Make sure you understand this. If you need help with this, please contact the instructors. But make sure that you can do this. This is the quickest way to do subnetting using variable lengths. Make sure you go from highest to lowest, and then just figure out the prefix of that network. Start with the first address, write down the prefix you discovered, and go from there. And it's very simple. Follow your chart.